And with that, I'm done. Thanks a lot for hearing me out. And you can find me on YouTube. You can find me on X. And yeah, thanks a lot.
Woohoo! Are we really calling it on X? Who's calling it still Twitter? Who's calling it X? Are you from the future? Seriously? Did you change it on the websites too? No, I'm still postponing that on my company. I'm not sure how can I manage to, but it's like very hard for me. I remember Chris in the morning saying that he's going to call it 10 because it's the Roman X there. Are we up and rolling?
Almost. Does my mic work?
Yes.
OK, if I hit play, no, that needs to come over here. And
Almost.
We're all going to be friends. I think this will work fine. 1 second. Yeah, it's going to be fine.
Seems to be good.
OK.
Let's roll.
Oh,
no, let's roll.
Let's go. Hey, everybody, what's up? I'm Jamund. I'm super stoked to talk about web performance. How many of you have a slow website? You're all lying. Everyone that has their hands down is probably lying. All right. This talk is called Monsters of Web Performance. I think it's a cute analogy, monsters, because monsters have all these lore and these secrets, and you can go to some wizard that will teach you how to destroy them and learn their weaknesses. And this is also the same, actually, for web performance. And once you learn those secrets yourself, right, it gives you a superpower, and you can go and train your team and teach them also how to fight those monsters and defeat them and keep them out of your applications. And even then, you can build systems and metrics and monitoring like they have here in Jurassic Park to keep those monsters out of your websites or amusement parks or whatever it is that you're building. So I think there's actually, the analogy works a couple ways. I'm pretty proud of it. Plus, it was just Halloween, so let's roll with it. The first monster I want to talk about is one of the cutest monsters. I don't know if you're all familiar with the abominable snow monster, sometimes called the Bumbler, from Rudolph the Red-Nosed Reindeer, like a 1960s show in America, but I'm going to refer to this one as the abominable bundler. And you all know exactly what I'm talking about, what this monster is, and I'm going to demonstrate it with a Slack message that I received, that was posted in a chat when I was at PayPal. And I know that this kind of thing, like, I don't know if you're familiar with web performance at all, it just like makes me cringe so bad. Like, everything about this is wrong. And the first thing I want to talk about is, why is the bundle so big? Like, what are they doing in their application that it's 9 megabytes? Any guesses? What's going to be in that bundle? Just shout it. What is it? Some server code? OK, any other ideas? What is it? Assets? Yeah, OK. It was flags. 7 megabytes of flags. You have an entire SVG array, 4x3, 1x1, all the flags. And this is from a NPM module that, like, surely when they brought this in, it solved the problem. Probably like a little select box needed to have a couple images or something, or maybe they're just super patriotic and want to show all the flags. I don't really know the story. But the thing is, this is not good. And so what do you do when you find stuff in your bundle that you realize you probably don't need, or that's that big, taking up that much space? You need to get out your pickaxe, first off, and start chipping away at that bundle using your dynamic import. So normally in JavaScript, we're using that static import, the import there. But if you use the dynamic import, the import function, you can pull stuff in on demand rather than all at once. So it splits that bundle up into little pieces, like our hero Yukon Cornelius here, breaking up the ice with his pickaxe. Obviously, it's important that you regularly inspect your JavaScript bundle. How many people have run Webpack Bundle Analyzer or similar in the last month? OK, we've got like a crowd here of enthusiasts, which I appreciate. The next thing I want to point out is that in the bundles, Like all the time, you'll get multiple versions of polyfills. I've seen 2 different versions of React before. Like I didn't even know that that should work, but I've seen it. There's a lot of bad stuff that can be in there. Now the second point, and the one that actually bothered me more than the first point, was the idea in that message, that Slack message, that somehow if we just moved to React, all of our problems would go away. And I just want to comment on this a little bit. Like if you have a problem and you take that problem with you somewhere else, the problem is going to remain. And so it's very likely if you're using some bad JavaScript, you pick up a new framework, you might still bring that NPM module with you, which is why I really, really want to stress the idea isn't that you can run away from your problems and say, oh, don't worry, we're just going to adopt a new framework. You actually need to learn how to identify and fight these web performance monsters because they're just going to follow you wherever you go. So that's kind of my speech. And really, obviously, I'm not done, but that's kind of my intro. What I really want to do with this talk is just get people hyped about the idea of making their websites more performant and taking it seriously. So let's talk about another monster. This one is one of my favorite monsters, No Face from Spirited Away. And this particular monster here is representing out-of-control CSS or UI libraries. And how many of you have had applications where you've got Bootstrap 2 and 3 and Semantic UI and Emotion and Radix and MUI and maybe Tailwind and probably styled components, like all ending up in the same application because you pull in one library and then you pull in a date picker from another thing and a modal from another thing. And then all of a sudden your UI stuff starts to get out of control. And you might feel for a minute like, it's probably fine, but I assure you it is not okay. And let me show you an example. When I was on a different team at Amazon, the seller listings team, we were building out a form where people could enter in information about products. And we knew it was pretty slow. It didn't feel very fast. And we'd run Lighthouse, and it would give us this recommendation to say things like, oh, you should remove unused CSS. And it's like, oh, thanks. What a good recommendation. If I knew how to do that, I probably would have done it already. And unfortunately, it's not very obvious how to do some of these things. But eventually, we found the tool, this show coverage tool, that gives some hints. And so the show coverage tool, you can run it on your application. It'll show you JavaScript and CSS, how much it uses of it. And then you can go line by line and actually see what CSS or which JavaScript's actually being used on the page so far. And when we ran this in our application, it turns out that we were using 1% of our CSS, which is pretty astonishing, considering our CSS file was 2 megabytes. It's just a bad thing, you know. Sometimes I'm out there making websites and they're horrible and I feel bad about them, but you know, you just got to keep on building and hopefully you get better as it goes. So this particular one, the problem is with your 2 megabyte CSS bundle, CSS is a render blocking resource, right? We know what that means. It means that if you have CSS in the head of your application, until that CSS is downloaded and processed and ready to go, your HTML isn't going to be rendered at all. So like you're not going to see anything until your CSS is ready. It's blocking all that rendering. And so having a giant file is a huge problem. In our case, we had this very strange code, which I didn't recognize until much later when I was really interested in this, what the problem was, where we were importing a UI library, and then we were importing a minified version of that UI library. Obviously, this was an astonishingly stupid thing to do, but I saw this code over and over again. I never even questioned it. I just thought, yeah, that's probably how you use this particular library. I hadn't used it before. Eventually, I tried the brilliant idea of just commenting out those imports, and it turns out our website only broke like a little bit. Like the modals didn't work, the grid system was off, but like it was fine. It was fine enough that we could just search and replace from the few references to that library to the other UI library that we already had in our bundle. And we were able to save 700 milliseconds off every single rendering of that page just by removing bloated extra CSS. So when it comes to this particular monster, keep an eye on that coverage percentage. Some modern tools, if you're only doing CSS and JS, it doesn't show up properly on the coverage tool, so I don't have any help there. But if you have a separate CSS bundle, you can look at through that tool. And obviously, like, actually stick to one UI library. Most of you kind of scoffed at that, but like if you look at your bundle, if you run your bundle analyzer, like I bet you got more than one thing in there. Like don't judge. And then there are some tools to help you automate this, but to be honest, I haven't been able to get them to work for me. So the next monster I want to talk about, this isn't much of a monster, but it's something that I thought was cute because their hats kind of look like loading spinners. This is Tweedledee and Tweedledum from Alice in Wonderland. And I think, and they're meant to represent here async data loading patterns. And the way that I'm thinking about them is you kind of have your super old school way of loading data, this sort of jQuery way, where you maybe reach out and grab some HTML and shove it into your DOM. It's not super common now, but people probably still use it. And then you've got kind of your Jamstack way, at least from the last couple of years, where you load your website, you then make a call to get some data, and then you'd render that data into your DOM using a framework or whatever. So let's talk about these two. On our seller listings page, we used to have these pop-ups that would tell you about taxes and fees and things that you had to pay. And this was loaded with jQuery.load, this old school function where basically we knew it was behind the behind the fold. It wasn't something you need to display immediately. And so we waited till the page loaded, and then we'd kick off this call to download all of these extra like pop-ups and like shove them in a hidden div until we actually needed them. Funny thing was, that particular call, when we'd run our performance analyzer, was super, super slow. And so we found out that this jQuery load call, all it was doing was taking HTML and shoving it into the DOM. But that parse HTML you can see there was taking a ton of time, 400 milliseconds, maybe even 700, up to 3,000 milliseconds, depending on how much HTML you were forcing it to process. And I kept being confused when I was trying to debug this, like, what's the function this is called? It's like, it's not the function, it's the browser. And the reason the browser's that slow is because we have too much HTML that we're trying to parse. If you had 200 rows in your table, we were loading 200 pop-ups worth of HTML and shoving it into the DOM, and like, yeah, it's gonna be slow. So, if you're dealing with this kind of pattern, try to make sure to remember that you only load what you need when you need it. You don't need to preload all the stuff that may eventually come. Let's talk now about, and obviously don't have too much HTML. Let's talk about now the Jamstack pattern that we're more familiar with. And this is something that I noticed. I learned how to recognize very, very quickly, and it sticks with me, which is this kind of, you can see it when you run the performance analyzer, but it's this. You download some HTML and JavaScript, your JavaScript processes, then you have this long wait for the data for your page to load. This is where your loading spinners are spinning or whatever. Then you render your data, and then finally your page is ready. So in this particular case, you can see that's the largest contentful paint at the end when everything is actually displayed on the page. And as you're going along, you see all these little red triangles. Does anyone know what those red triangles are? Just shout it out. Yeah, exactly. So if you have a long-running task, a task that's over 50 milliseconds blocking your main thread in JavaScript, it's going to be flagged like this in the performance profiler in Chrome, which is super helpful to identify when you're doing stuff that's going to potentially create lag or poor performance of your application. So not only do we have some long-running tasks, we have this massive wait for data. So to make it even worse, you can go into your network tab and you can use throttling to actually better simulate what some of your customers are using. If you can also, in the network tab, look at the timing section. So find your main requests for data for your page, look at the timing section, and oftentimes you'll see that it won't be queued and started up, actually run for some hundreds or thousands of milliseconds after your page actually starts being loaded. So the idea here is, wait a second, you need this data. This is critical data to render your page. If you're delaying that time when you actually make that initial call, you're seriously slowing down your site. So I have a whole blog post about this, whatever, you can look it up later. But let me give you the super short recap version of how you can try and optimize these sites, because this is a very common in any kind of single page apps that we still use a lot today. The first thing you want to do is pre-fetch the data. So start loading your main data as soon as possible. Don't wait until deeply nested in React. Like, put your fetch call basically like at the top of your index.js, not deep in some tree that has to be parsed and rendered first. And the second thing, if you want to go even a bit mega on it, is find a way to parallelize loading the data with loading your JavaScript. So instead of having, let's say you have a 1 megabyte JavaScript bundle. Okay, so even if you start loading your call at the beginning of that JavaScript bundle, you still have to download and parse all that JavaScript before it runs. What about if we just have a completely separate 2 kilobyte JavaScript bundle? They can run they can start downloading in parallel with your 1 megabyte JavaScript bundle and start loading the data so that by the time the data is ready, your JavaScript application is ready to render right there, saving a ton of time. These are some of the techniques you can use now. Super modern frameworks like Remix and like some of the React server components, they kind of address some of these issues in a different way, but you don't have to run to those new frameworks to solve some of these problems. You can solve them right now using some of the techniques I talked about. So for this one, really get familiar with that, with the browser network and performance tabs. Just like use them pretty regularly, analyze your app, understand what's happening, and you can get so much out of it. And then obviously just load that data faster. If you're dependent on data to render your page, get that data loading as soon as possible. Let's talk about something else. These little creepy crawlies that are hidden in your application, little things in there slowing down your typing and your scrolling and creating jankiness. And we see these all the time. I had the form I was working on recently, and when you click submit, if the form was good, everything was happy. But if you had a validation error, we started this infinite loop of validation. And it's this, the culprit in our particular case was that very common problem of having the wrong dependencies in our use effect hook. And the wrong dependencies in the use effect hook triggered an infinite loop. And this is such a problem that there's literally like a whole blog post in the React dev site about how to avoid this problem. This isn't the only way to make your website slow, though. Unfortunately, there's 1,000 different ways, and I can't cover them all. I want to share one other silly one that I did. Back in the seller listings page, we had this tab, and when you switch tabs, we were noticing it was taking a super long time, 700 milliseconds, maybe 1.5 seconds, just to switch tabs in a form. It shouldn't take that long at all. And it turns out what we'd done is we set up this form validation once again, but it was based on Redux. And what we did is when you change tabs, it was firing off these events for every single element in your form, firing off these actions. And again, there's a whole blog post in the Redux style guide saying like, or a whole section in the Redux style guide saying like, avoid dispatching many actions sequentially. Like, I read that after we came up with the way that we were doing validation. I learned this later, obviously from experience, but it was, it's just interesting to see how many different ways. Like, it's amazing how easy it is to make a slow website. It will just come to you. It's like a natural ability as a programmer. You can make something bad. It's just like, it's magic. So what do? Use a performance profiler and see what's happening. You can look in there. You can see when events fire, and then you can see how long things take. So one thing I often do is I hit that record button, and I start typing in a form element, and just see like how slow is each of those type events? How slow does it respond to a click and these different things? And you can really start to understand what's going on that way. Then the other tool that I highly recommend is React Developer Tools. So useful, especially the profiler, because the normal browser profiler does not do a super good job of understanding React, because React has so many weird things it does, and it's hard to understand. And the performance profiler will just tell you like straight up, here are your components, here's how long they took to render, here's what they rendered. And if you go in, there's a section where you can turn on the ability to record why each component rendered, which I highly recommend, because that'll show you exactly what's going on and why. So again, go in here, hit the record button, interact with your page a little bit, and come back and see what happened. Did it render 40 times when you just typed 3 characters in a text box? Like, maybe that's a problem. Maybe you should figure out what happened. So stepping back a little bit, these ways of measuring your site in a controlled environment is referred to as a lab test. And you know, there's other ways you can do this in like a CI where it's consistently recorded. But what's also critical, and I've seen it in some other talks, is getting data from the field to understand what your users are actually experiencing. This is called real user monitoring. And there's tools out there like AWS CloudWatch RUM, Sentry, and others that will help you understand this. They'll let you not only see like standard web performance stuff, but also allow you to log custom metrics so that you can better understand specific important interactions in your page. So to deal with some of these creepy crawlies, what I recommend is 2 slow animation. 1, get comfortable with the performance profilers. 2, identify and measure key interactions. So figure out what are the most important things from a UX perspective that your users want to do. Figure out how to measure them in an automated way. So it's not just you, with a timer there, but actually so it's recorded regularly through metrics and stuff. And then set a performance budget. So figure out, OK, this interaction, for example, changing tabs within a form should only take 250 milliseconds on average. And actually figure out how to measure that in a consistent way. So if you go above the budget, you can actually invest in fixing it. So to summarize all the things that I talked about today, we spoke about 4 monsters, we spoke about 7 tools, and 10 different techniques for addressing web performance in your applications. I hope you learned something, I hope you have fun, and I hope you want to come and fight the monsters of web performance with me. Thank you so much.